Okay, I'm back. Let's look at numbers 3 and 4 here, maybe even 5, depending on how long this video seems to be going. Okay, so this time they give me the equation, which is what we're used to getting. We're used to getting the equation, and now we're going to figure everything else out. Well, when they give you the equation, you know a couple things. We could do M behavior, but this is in factored form, which screams, look at me, here are the roots. So the roots are at 1, and that's a multiplicity 1. And then we have -3, which is multiplicity 2. Now that multiplicity 2 is going to show up as a bounce, okay? So we have one of the x-intercepts will be at 1, and then the bounce will be at -3, okay? And that tells us what the degree is. The degree is going to be 3. So if the degree is 3, and we have a positive stretch factor here, it's going to be a positive snake baby. So our M behavior is, as x goes to -infinity, as x goes to the left, I'm on the wrong question here. As x goes to the left, this is going down to -infinity, and as x goes to the right, it is going up. The value of the leading coefficient, it just told us what that was right away. Snake babies have -infinity to +infinity domain are all real numbers. All polynomials have no risk factors. So they all have -infinity to +infinity. The range is different. The range on odd degree polynomials is all real numbers. But if you remember question 2, when we had the W looking thing, the range would have a bottom out there. Okay, so now let's graph it. I'm going to go ahead and do my y-intercept before I graph. I bet you did not. But if you plug in 0 for x, I will get 2 times -1 times 3 squared, which is -18. That tells me that my graph is going to go off the charts here, and it'll be way down here at 18. So at this point, what I would do is I would just go ahead and plug this factored form into my calculator and see what I'm looking at. So where is my calculator? Did I close that little jerk? Great. Just had it out. Okay. Sorry that happened. There's the graph from before. Okay, so y equals, be careful when you type things in factored form. So 2 parenthesis x minus 1, close the parenthesis, start the parenthesis, and then x plus 3, close the parenthesis, squared. Okay, so here's a graph. And if I look at my table, which might be helpful here, yeah, there's that -18 that I saw. If I go back to the graph again, I can even see the minimum that's going to happen here. So it's not really that important for the sketch. This is going to be the bounce that we talked about and the relative max. So basically, I'm just not going to give a very good graph here. I'm just going to go straight down here. And I'm going to go whoop, and then it's going to come back up. So this is going to be a really garbagey graph, but most of the action was away from where I did. I guess I could have changed my scale if I wanted, but I didn't. So we're just going to leave it as that. So question 3 was a little quicker than some of the others. Question 4. What did they tell me here? Oh, they told me the roots. So they just said function. It didn't say if it had to be standard or not. And if they told me the roots, I'm going to write it in factored form. Okay, so this one first. 0, 0 means x is going to be a root. Multiplicity 2 means x squared is going to be a root. And then what I have here, I have a 3. Change the sign. It's an x minus 3, and then an x plus 1, and that will be squared. Okay, be very careful. I almost missed this. It says that -1 is the leading coefficient, so that means you have to put a negative here as well. Okay, so what is the degree here? What I have here, I have 2, 3, 4, 5. The degree is 5, which means snake baby, but the negative coefficient flips it upside down, so it'll be like this. And that's why as x goes to -infinity, f of x is going up. And as it goes to the right, it's going down. It's an arrow. It doesn't look like one. So what is the domain and range? We just talked about that. The domain for all polynomials is -infinity to +infinity. And this one, because it goes up and down forever, the range is also -infinity to +infinity. So if you want to look at the graph at this point, whoop, that wasn't too bad. Go ahead and plot your x-intercepts. So I have a 0. That's going to be a bounce, guys. A -1 is going to be a bounce. Ooh, so that's going to be weird. How's that going to work out? And then 3 is going to be a straight pass through. And it has to end down. So I know this is going to go downwards. So then somehow it needs to start up here. And then what's going to do? It has to bounce and bounce. So what's going to happen is there's going to be like a little bounce here. I mean, I guess it's going to be a big bounce. But there's going to be a bounce here. And then there's going to have to be a turnaround somewhere else too, I guess. Bounce. Is this a bounce? Yeah. Bounce. Bounce. And then back down. I don't know. Let's see what the graph tells us. Y equals -x² parenthesis. Oh my gosh, what did I do? What did I do? Negative. I'm just going to clear this out. It's hard with all this stuff on top of it. You guys are like, she's so stupid. Okay, -x, or you might be watching, which that's fine too. I don't. At this point in the game, guys, we're just doing the best we can. X plus 1 squared. Neat, neat. Okay, let's look at it. What happened? Ooh, yeah. Okay, so yeah, it went up high here. And then there's a little bounce here. So how high did it go? I don't know. I can look at my table. What happened between 0 and 3? Oh, we're all the way up at 36 here. Yeah, I'm not going to graph that. But I'm interested in that little bounce. If I go back, I'm kind of interested in this. You don't have to get exact here, but if you go to zoom, if you just zoom in once, zoom 2, there's a little bounce that we were talking about. You can actually find that. Second, calculate maximum. And if you want to be more accurate with your graph, you can that way. What's it say? Yeah, like -0.5, 0.2. Yeah, so it doesn't go up very high at all. And then the other thing went up way high, so I'm not even going to worry too much about it. So it goes way up, but then it comes back down and passes through. Okay, so that's about as good as I'm going to get for you. I think I have time for one more on this video. This one doesn't seem quite as long. Oh, this one is pretty good because this time they give me the graph, which actually used to not be able to do this, but I can give you the graph and you can come up with the equation now if they tell you some hints. Okay, so this looks like that there's a root at -2 and it's a bounce. So that's a multiplicity 2. And this is a 2 with multiplicity 2. So I can go ahead and, knowing that they had to tell you this, the leading coefficient, but once they did, you can go ahead and write that equation. It's going to be an x plus 2 squared and an x minus 2 squared. And because the degree is 4, it makes sense. So the end behavior is x goes to -infinity. This guy's going up, and this guy's going up to the right as well. The y-intercept is 16, 0, 16. That's all that tells me, and he's right. And now all I need to know is the domain and range. The domain is -infinity to +infinity because you can go to the left and right forever. But this one, I can go up forever, but I cannot go down forever. I'm stopping at 0. And it put a square bracket because it can be 0, but it will never be below that. But it will go up forever. Okay, that's a good stopping point for this.